Hi everyone. In this video I want to talk about the kinetic energy of a moving object. When we think about the kinetic energy of a moving object, there's two things that we need to think about. How fast is it moving? And how heavy is it? When we think about how heavy something is, in physics we talk about mass. When we think about how fast something is, we talk about speed. Now, if a body has kinetic energy, then it's able to do some work. A hammerhead has kinetic energy. When it's swinging down, it can knock a nail into wood. Billiard balls or pool balls, one cue ball moving along the table can make another cue ball move. And of course, a bulldozer can move along the ground and then move some sand, do work on the sand. And we always remember that energy is the ability to do work. Kinetic energy can't just appear from nowhere, however. Kinetic energy has to come from somewhere. If you're the SpaceX Falcon Heavy rocket, then your kinetic energy has got to come from the chemical potential energy in your fuel tanks. A rock flying through the air might get its kinetic energy from the elastic potential energy in a slingshot. And if you're riding a bike at some sort of fun competition, your kinetic energy might come from your friends pushing the bike behind you, or should we say trike. Equally, kinetic energy can be removed from a moving object. A trapeze acrobat can have her kinetic energy removed from her as she falls into the net, and it becomes elastic potential energy in the net. A fighter jet can have its kinetic energy removed by the arresting cord as it lands on the aircraft carrier, and then it becomes elastic potential energy and heat. A rocket capsule entering back into the Earth's atmosphere after being in orbit can be slowed down as its kinetic energy is transformed into heat due to the friction it experiences going through the atmosphere. So kinetic energy is to do with speed and it's to do with mass. And we see three objects here with very different speed, very different mass, very different kinetic energies across all of them. So let's go into a couple of thought experiments. In physics we like thought experiments. And we ask ourselves, what has more kinetic energy in this thought experiment? A Tour de France competitor racing downhill, or a weary teacher on his way home after work? Well, both of them are pretty similar in their mass, but one is clearly going a lot faster than the other. So if you said the Tour de France competitor, then you're right. He has more kinetic energy because he's so much faster. Kinetic energy is linked to speed. Speed is linked to kinetic energy. The faster something is, the more kinetic energy it has. Here's another thought experiment. We look here, we can see a road train and we can see a car. And they're going pretty much at the same speed because the road train is trapped behind the car. So they're going at the same speed. So what has more kinetic energy? The road train or the car? Which one would be harder to stop? Which one would do more work if it crashed into you? Kinetic energy and mass are definitely linked. The heavier something is, the more kinetic energy it has. If I ran into the side of a four-wheel drive, I wouldn't be able to shift it, but a rhino can because it's so heavy. So now we can see that mass is linked to kinetic energy and speed is linked to kinetic energy. But if you give an object kinetic energy, does the mass of the object influence its speed? How do mass and speed relate when an object has kinetic energy? Does the mass of an object influence how fast it can go when it's given a certain amount of kinetic energy? We can investigate this using a trolley, 4 masses, an elastic band and a chair. The trolley is 600 grams, the 4 masses are 500 grams each, and we've got the elastic band to provide the energy. If we pull back the elastic band a certain amount, we'll have a certain amount of elastic potential energy which can become kinetic energy. If we always pull back the band the same amount, and we just change the amount of weight that's on the trolley, then we can give the same kinetic energy to each trial but we'll vary the mass, and we'll see how that influences the speed of the trolley as it moves across a 2-metre space, or a 2-metre length. You see here the carpet squares are 50 centimetres each, so 4 of them is 2 metres. Okay, so now we're ready to go. Our trolley has got 3 of the masses on it. The trolley is 600 grams and the 3 masses are 500 grams each, so that takes us up to 2.1 kilos. We've got a little piece of tape to mark how far we pull back the elastic band to make sure that we give the same amount of elastic potential energy every time. So we pull the trolley back to the tape. We've got 2.1 kilos there, and we can see the speed that it goes. Now we've got the trolley just by itself. That's 600 grams, 0.6 kilos, and it's a lot faster. Let's see them both again. 2.1 kilos with our set amount of energy, slower. 0.6 kilos with the same amount of energy, faster. So kinetic energy is linked to mass and speed. I hope this was helpful for you. If it has a certain amount of kinetic energy, the heavier it is, the slower it goes.